you around who the learner or the student of this course is.
Yeah, so I think the learner is someone who's never programmed before.
Wait, when you say never, do you mean no lines of code?
0.
0 lines of code?
Yeah.
Wow, that's going to be a tough course for us to design, but it's going to open up the gambit for everybody to take this course.
Absolutely. I think that's why it's so powerful. Because at the end of this course, I think they should be able to build a couple of simple Android apps.
Wait, let's backtrack a little bit. So we're saying no lines of code, no programming experience, but we're still saying you need a computer and you need an internet connection.
Yeah, and to have some familiarity with using a computer and a smartphone.
So you've browsed the internet, let's say, on a smartphone or a computer.
Yeah.
Okay, well, let's say this is where the student is right now.
Okay.
Right? And this is where a professional Android developer is, right? This is where they're making apps, they're making money, they're changing the world.
Okay.
Let's say this is where we will get them at the end of our course.
I think we can get them to here.
Okay, so in this journey that the student is taking with us, what sort of apps are they building here?
Yeah, so the first app is a birthday card app.
Wait, you said first app, so there's more than one app?
Yeah, so first there's a birthday card app where they can make it for someone that
like
they
that.
love.
I like it. People have birthdays, sometimes they even have half birthdays.
Yeah, and the second app should be a coffee ordering app.
So you say, I want 2 cappuccinos, and 2 cappuccinos appear magically from the phone.
Not quite, but it captures what the user wants to order, and then it sends it off in an email.
Okay, so in this journey that we've been sort of dreaming up, how long will it take the student so they can budget their time appropriately?
Hopefully 20, 25 hours.
I think that's about right. You know,
Okay.
it'll take a lot of deliberate practice. They'll make a couple of fun apps. But what they can do is they can take this 25 hours and split this up into 4 to 5 weeks worth of their time.
Yeah, I think that sounds good.
So that's as much about the course and about us. At this point, I want to ask our students a question.
Tell us about a time when you were learning something new and you had to struggle.
Okay, Catherine. If we're going to ask our students to share their vulnerable stories on the internet,
Yeah.
we have to lead by example.
Okay, fair enough. You go first.
Okay. Well, I've been learning to play the piano for about 8 months.
Oh, okay.
And the toughest bits for me have been, you know, getting one hand right and then getting the right hand right and then putting those two things together. But when it comes out, it's just so beautiful. It's like, da 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 da.
Wow, that sounds really good.
I've been playing for my friends. It's really fun.
Wait, you haven't played for me.
Well, we'll see if we stay friends till the end of this course.
Okay, then.
Your turn.
All right. I've struggled with learning Chinese my whole life.
Wait, you speak Chinese?
Yeah. 你好，我叫李秀贤. It's no big deal. So I think the hardest part of learning Chinese has been trying to learn all the vocab words and trying to put them together in complete sentences without tripping up.
You know, this story of yours is reminding me that learning how to make an Android app is like learning a new language.
Okay, I can see
So you're learning a new vocabulary and you're putting those things together and, you know, programming sentences and creating an app. Okay, well, those are our stories. Now I want our students to share their vulnerable stories. Tell us about a time when you learned something new and it was a struggle.
that. Okay, we just signed up for a lot. We have so many things to teach them.
Yeah.
What should we cover?
You know, hold that thought. I need something.
Where are you going?
Here. This is for you.
Thank you.
Let's just pour out some beans on it.
What are you doing?
Well, these are not our beans, but let's just imagine they are for a second.
Okay.
Okay, I just want to create a little coffee trail, which is
Okay.
going to be a symbol of the journey our students will take with us.
Okay, I like
So let's
that.
just say this is our student, and this is where they are beginning.
Oh, and then this can be where they end.
Right, which is where they are an Android developer.
Yeah.
Right, and we're focusing on just this part of our course right now, right? So this is where we are. So I'm just going to clean it out and zoom in into the main part of the course. Okay, well, let's say there are 3 big lessons in this course.
Only 3?
Let's say there are 3 for now, yeah? So this is lesson 1, 2, and 3. Let's talk about lesson 1. I'm just going to zoom in there and clear out the
that.
rest, yeah? Well, I'm going to split this further into 3 sections, and you might guess what my favorite number is at this point, which is
2?
3. What is the first thing we should do in lesson 1?
I think they should learn about views.
Oh, views, things that you see on the phone. So like a checkbox, a radio button, an image, a text of some sort.
Yeah, exactly.
So we introduce them to that here in the second part of lesson 1.
Then they can learn to customize those views.
Oh, okay. So you're changing the color of a font or size of an image.
Exactly. And then part 3, we should teach them how to position views on a screen.
So it's like bottom left or top right, or where is it going on the phone screen?
Yeah.
Good. So let's begin at the beginning.
The first thing in Android you need to know is something called views.
Views.
Let's talk about views.
Wait, what was that sound, Catherine? Whoa.
Oh, that's the sound when there's a new vocab word that pops up. It'll show up on screen, and you can also check the instructor notes for more information about it.
So at the end of the course, you will have access to all of the new words that we're using in this course.
Exactly, so you don't have to feel like you have to memorize it or anything.
Let's talk about views.
Step 1 is about picking the views that you want to use. First, I should explain what exactly a view in Android is. Simply put, a view is a rectangle on the screen that shows some content. It can be an image, a piece of text, or a button, or anything else that the app can display. Now, these individual views make up what we call the layout of the screen. Everything about what you see and interact with in your app is called the user interface, or UI for short. There are different types of views with different names. A view that shows some text is called a text view. Here are some examples. A view that shows an image is called an image view, and these are some examples. A view that shows a button is called, well, a button, and these are some examples. Now, there are many other types of views in Android which are really helpful to use, but we're going to focus on these three first. Earlier I mentioned that every view is a rectangle on the screen, but where are all the rectangles? Well, technically they're invisible, but I will draw them for you so you can see where the bounds of each rectangle is. As you can see, every app can be broken down into the individual views that make it up. In other words, a view is the basic building block that you use to build up the layout for your app. To help you understand the idea of views being rectangles on the screen, here's a situation you may be more familiar with. If you ever use an application like Paint or Google Drawings, then you may have added a text box to the canvas. Then you type in your text. If you click outside of it, though, you don't see the bounds of the rectangle, but they are there. And the bounds actually do start to matter when you start to do things like adding a background color or adding a border around it. Then it does matter how big the rectangle is. I also want to point out that the format of these view names is in camel case. Camel case means that there are no spaces in between words, and the beginning of each word is capitalized. The reason why it's called camel case is because the outline of the word goes up and down like the humps of a camel's back. You're going to be seeing camel case more throughout this course. Okay, let's practice what you learned. This is a screenshot of the new email app from Google called Inbox. Can you identify the different types of views here? To help you, I've highlighted the individual views. For example, for A, can you tell me if it's a text view, an image view, or a button? Do the same for B, as well as the rest of the views. Let's go over the solution together. First, at the top of the screen, we have this blue envelope with a checkbox. This is an image, so this is what we call an image view. Next, we have these three pieces of text, and there are three different text views because they each have different font styles in terms of font size and font color. And they're also positioned in three different places on the screen. So we mark these as text views. The last one here is a button that the user can tap to sign in, so we choose button. Good job if you got those answers correct, but if not, no worries, we're going to practice some more. Now you know about a couple of different views like text view, image view, and button that you can use in making Android apps. But now I have another challenge for you.
The YouTube challenge.
Okay, this is a screenshot of the YouTube app when you first come into it. Look at it for a moment, and can you imagine where the view bounds would go? You can pause the video while you think for a second. Okay, so this is where I would draw them. And now I want you to identify whether each of these views is a text view, an image view, or a button. Okay, so looking at this screenshot, there are two text views at the top. And I can say this because they have two different text styles. For example, this one is a little bit bigger and a little bit bolder. And now we have the YouTube logo, which is this red icon. And so we use an image view to display it. And then last but not least, we have two buttons at the bottom that you can tap to skip or go to next. And we're done, so we can move on now. Hey Kunal, what are you doing?
Oh, I just need a minute.
What you writing?
Well, why are you looking at my
I
email?
just want to see what you're doing.
Okay, fine. I'm sending an email to a friend which has
okay.
instructions on how to feed Chloe.
Who's Chloe?
Oh, Chloe's my office plant.
You named your office plant Chloe?
Yeah, Chloe for chlorophyll.
Clever.
Look, here it is.
Oh, okay. You know what this reminds me of?
What?
These instructions are similar to how we write code to tell a computer what to do.
You know, everything reminds you of how to write instructions or code, Catherine.
It does. But I'm serious, this time it does. It's
Okay.
sort of like here, this line where you're saying that you need to water the plant exactly on Tuesday at 10 o'clock.
Right, so when I'm giving specific instructions on Tuesdays and Thursdays, water the plant or make sure the water is lukewarm, those specific instructions are like writing code.
Exactly.
Okay.
And you know how you're writing this letter in an email app?
Yeah, I'm using Gmail.
Good choice.
Shameless plug.
We also need a space to write our code.
Sure.
And that space is called an IDE.
What does that stand for?
Stands for Integrated Development Environment.
I am more confused after listening to the full form of that acronym when I heard the acronym. in the first
Well,
place.
don't worry about what
Okay.
it stands for.
Okay.
In Android, all you need to know is that we're going to use Android Studio.
Is that on this computer? That software?
Yeah, it's right here. Let me show you.
Oh, and this is what it looks like.
Yeah.
Huh. You know, I must admit that this looks a little bit intimidating. It has a lot of buttons on it.
It is. There's a lot of things going on,
Yeah.
but we'll get there.
By the end of the course, the students will know how to operate this.
Yeah.
Okay, good.
Cool. So back to your letter.
Okay.
Oh, you know how you're using English to write this letter?
Well, it's a great observation. I thought you said you were not reading my email, but yes, I am using English.
Okay. Well, we have to use a certain language to talk to the computer
Sure.
to give it instructions.
What are we using?
We're going to start with XML.
You know, Catherine, you're a fan of three-lettered acronyms, it seems. First IDE, now XML. What does XML stand for?
It stands for Extensible Markup Language.
Extensible markup language. What does extensible ML do?
It is a way to describe how your Android app is going to look.
Okay.
So we can use it to build layouts.
Okay, so where you're going to place things, what things you're going to place on the phone.
Exactly.
Okay, well, there's a lot going on in this video, so let's
Yeah.
just do a quick recap, right? We're talking about how writing code is like writing instructions, really specific instructions. Right. We're also talking about how we need a space in which to write that code.
And that space will be Android Studio,
And we also identified the programming language we will be using.
which is XML.
So let's write our first line of XML.
Yeah. Okay, now we're going to start looking at code. This is going to be for the text view, which displays text on the screen. If I write this block of code, then the phone looks like this. Now I know this may look a little funny to you, because it's not like the normal words and sentences that we're used to every day. We're going to go over this in a little bit, but first I want you to make some observations about this code. Write at least 3 things you notice about the code. Include things that make sense, as well as things that are strange or confusing to you. Thanks for your response. There's no right or wrong answer here, so let's talk about a couple of observations that you may have made. First, you may have seen that there's these weird angle brackets at the start and end of the code. There's also this weird /, but it only happens at the end but not the beginning. And then it says TextView, which we recognize because we introduced it earlier. And it's showing up in camel case format with the T and the V capitalized. And then you might see something about Android :text, and the punctuation might be a little weird here, to have a colon and then an equal sign. Then we see something that says happy birthday, and this is showing up exactly like we see on the phone, so somehow they may be related. So this can be an observation as well. Then we see something about a background being some color that's darker gray. And the text view does have a gray background, so this could also be linked. You made some good observations in the last quiz about the XML that we showed you. Now we're going to talk more formally about the XML syntax. Syntax means the rules that define what valid XML is. If you write invalid XML, then it won't even show up on your phone. This is the code for the XML element called TextView. We always start with an opening angle bracket followed by the view name. This could be ImageView, button, or any other type of view. Then we have a list of attributes here, 1 per line. And then we have a / and then a closing angle bracket. There's a lot of symbols and characters here. To help you remember it, you can think of an opening angle bracket, ding, and then the view name, whoosh, and then the attributes, pew, 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 and then the /, and then the closing angle bracket, boom. So altogether it's ding, whoosh, pew, 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 boom. If you miss any of these symbols, then you're going to get invalid XML. Here's the reasoning behind what seem to be arbitrary symbols. For every XML element, when you start or open up a tag, you always need to close it. It's kind of like putting a period at the end of a sentence, but for XML, instead of a sentence, you need to make sure you close each tag. Because we start the tag here and then close it right away, this is called a self-closing tag. Instead of a self-closing tag, you could have a separate opening tag and a separate closing tag. Here's an example where it would be useful. This is for the linear layout view, which is what you're going to learn later in this lesson. But just know that this is the opening tag and this is the closing tag. The closing tag is the same, except it has an open angle bracket, a forward slash, the name of the view, and then a closing angle bracket. So the difference between the opening and the closing tag is this forward slash. And you'll also notice that in between we have two TextView XML elements. These are also called children XML elements within the parent linear layout. You can imagine that if you had a self-closing tag up here for linear layout, then you would have no idea how many children it contains. But now that the closing tag is down here, you know exactly that you have two children. In our case, for the text view, there are no children XML elements, so we can just do a self-closing tag right away because that saves us from having to write open angle bracket slash text view closing angle bracket. You'll notice that we have a bunch of additional text inside this tag. These are called attributes. Attributes are characteristics that determine the behavior or the appearance of the view on the Android phone. For example, you can think of it with this analogy. A person has attributes like black hair and brown eyes. A text view has attributes like width, height, background, text, among many others. Looking more closely at the format of each line, we have the attribute name on the left-hand side, underlined in yellow here, and on the right-hand side we have the actual value. It's important to note that the attribute values should be put in quotation marks as part of the syntax for XML. Then we have an equal sign in the middle to say that the attribute name on the left is set to the value on the right. So the text for the text view is happy birthday, and the height is 75 density independent pixels. All of these attributes have default values, and there's attributes that we didn't even list here. That's because the text view has default values for all of its attributes. If you're okay with the default values, then you don't need to set them here. You should only write lines of code here that you want to be different than the default values. For example, the default background color for a text view is a transparent color, but we wanted to set it to be a darker gray color, so that's why we have this line of code here. One more important note. Humans are pretty smart. If I write phrases like this, you probably know what I mean, even if I'm not using proper English punctuation or grammar, or even real words. However, computers are not as smart, so you need to use the precise symbols and names that they recognize. Otherwise, they won't know what you mean, and there will be errors in your code. Here's an example. For the name of the view, we can't spell it TXTView, or TextView with a lowercase v, or TextView with a space in it. These are all incorrect, and the computer won't know that we actually mean TextView. If we want TextView, we need to spell it exactly the same way with a capital T and a capital V for camel case. Attribute names need to be spelled out this exact way with a colon after the Android. We need to have an equal sign, and then we need to put quotes around the values. One more time so you don't forget, it's ding, whoosh, pew, 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 boom. Now that we've gone over the syntax rules of XML, can you answer these questions for this XML element? First, what is the name of this XML element? Then, can you list all the attribute names separated by commas, not the attribute values? Then, on what line number is the tag closed? To help you, I've written down the line numbers on the left-hand side. The answer to the first question is that the XML element name is here, TextView. It follows the open angle bracket. Then all the attributes are below the XML element name, and I've underlined the attribute names here. They're on the left-hand side of the equal sign. They include Android text color, and so on. If you put the attribute values like happy birthday or the color white or black, that's incorrect because those are the attribute values, and I was asking for the names. The last question is, on what line number is the tag closed? And we see the forward slash and the closing angle bracket on the last line, which is line 6. This means that it's a self-closing tag because we open the TextView tag here and then we close it right away.
Okay, so we've seen TextView code for the first time.
But it's kind of hanging out in limbo.
Right. We do need a space where we can sort of house it.
Yeah, and that space is an IDE.
Wait, there's that acronym again.
Yeah.
What did it stand for, Catherine?
Integrated Development Environment.
Right. And we are going to be using Android Studio in this class. This is what it looks like. Still a little intimidating.
Yeah, I think we might need something that will help our learner ramp up a little bit easier.
Right. So we've been working on developing something that is Android Studio on training wheels, and in the tradition of really convoluted acronyms in computer science, we are calling it XMLV.
Which stands for XML Visualizer.
So you write a little bit of XML, you get to see the output. You write some more, you get to see more output.
Yeah, so let's go use it.
Okay.
Since this XML Visualizer was created specifically for this course, it won't provide all the functionality that Android Studio supports. But eventually, in the problem set of this lesson, we'll get you into Android Studio so you won't need this website anymore. A link is in the instructor notes if you want to follow along. For this code, the text says happy birthday, so when I look at the device, it says happy birthday. Now let's try to change the text to happy birthday, Kunal. And then when I zoom in on the device preview, you see that it says happy birthday, Kunal. Now what happens if I try to change the width and the height? I'll pick some arbitrary values like 300 dp for the width and 500 dp for the height. And now in the preview pane, you see that the text view is a lot bigger. The text, though, however, is still the same size in the top left corner. Notice that for the width and height values of 300 and 500, it is followed by dp in each case. This is a unit of measure, like centimeters or millimeters, that we use to describe the size of views on Android, as well as the distance in between views. The unit dp stands for density independent pixels. Let me explain why we need that. Say these beautifully drawn rectangles represent different devices. They're the same physical size, but they differ in terms of resolution. This is a medium resolution device with a medium number of pixels on the screen, high resolution, and an extra high resolution device. When I say pixel, I mean a phone screen is made up of many tiny squares which are pixels, and they light up based on what you're looking at. So if I define the size of a view, for example a button, to be 2 pixels tall by 2 pixels wide, this is what it would look like on a medium resolution device. On a high resolution device, it would also be 2 pixels by 2 pixels, but it's a little bit smaller because there's a lot more pixels trying to be packed into this device. And then on an extra high resolution device, where there's tons more pixels packed into this space, this button is actually pretty tiny. I can barely tap on it with my finger. I have to use the edge of my finger or my fingernail to reach it. Just because I have an extra high resolution device doesn't mean I have a smaller finger. I still want to be able to tap the buttons on the screen. And that is why we have density independent pixels. I can define my button to be 2 dips tall by 2 dips wide. And this is what it would look like across the different devices. It's the same physical size, but under the hood, Android is mapping it to a different number of pixels. You don't have to worry about any of that logic. All you need to remember is that you need to define your sizes in terms of dip values. When designing your apps, we recommend that all touch targets, like buttons, should be at least 48 dips tall and wide. Notice that it says 48 dips and not 48 pixels. Otherwise, it would be really tiny on this extra high resolution device. This will make your app easy to use for everyone. So with all of this knowledge, I want you to try and change the TextView code now. You're going to be writing your very first lines of XML. How exciting! So first try to change the text in the text view, and then try to change the size of the text view. Then I want you to try to create an error, sad face, and then I want you to undo it, happy face. Alright, so first we load up the web page that was linked in the instructor notes. We see that it's populated already with some code for the happy birthday text view, and then on the right we see the preview in the device. To change the text that appears here, we need to change the value of the attribute called Android:text. So in between the quotes here, we can change the message. We can change it to Happy birthday to my pet hamster. Then on the device, we can see that the text has now been updated. Woohoo! To change the size of the view, we can modify the width and height attribute values. So in between the quotations, we can delete that and change it to something like 250 dp. And then for the height, we can change it to like 450 dp. And now we see that the text view with the gray background is now a lot bigger. Cool. So the last part of the quiz was to try to create an error. So if I delete the / and the angle bracket, then I get a bunch of errors that show up on the bottom here. Also, the device grays out because there's no valid preview to show on the device anymore. These errors can help you fix your code, but since we know what we need to do to fix it, we can just hit Ctrl-Z to undo the changes we made. The undo shortcut is really useful to use, so it's Command-Z on a Mac or Ctrl-Z on Windows. We can create other errors as well, such as deleting a quotation mark, and then we see the error down here. We can hit undo to make it come back. Or we can change darker gray to Parker gray, which apparently Android doesn't recognize, unfortunately. So we can just switch it back. The reason why we asked you the last question about creating an error and fixing the error is because an important skill of developers is to be able to get past errors. There's no developer who writes code perfectly the first time. If you think about it, like the whole Google search product was not written in one day perfectly. It was a lot of iteration over many years, and it continues to be. So regardless of whether you're a new developer or you're an experienced developer, in order to get to the end goal, it's not exactly a straight path. You'll run into obstacles along the way, and you have to be really creative in terms of trying to come up with other solutions to go around that obstacle. So once you get around it, then you'll run into another obstacle, and so on. And you just always want to keep thinking of ways to get around that obstacle. And eventually, after a lot of work, you finally find the path to the goal. And even though it was super challenging, it was totally worth it in the end because you feel empowered and confident and just really proud of your work. So the really good developers know how to rebound from an error and continue with their work. So here are some habits and strategies that they use to debug or fix their errors. First, they read the error message. When you're writing a document in Google Docs, for example, if there's any misspellings, then it will tell you with a red underline. Similarly, in Android Studio, if you have typed XML incorrectly, then it will have a red squiggly underline or it will be highlighted in red. Also, in this bar on the side here, it will show you the message if you hover over the red bar. In our XML visualizer, there's also helpful error messages. So if I create an error, like removing this quotation mark, it will tell me that there's an uneven number of quotes and that I need to fix it. Sometimes it also tells you the line number that the problem is on. The line numbers are on the left-hand side here. So on line 6, we know that there's a problem. This helps narrow down the problem space instead of having to read through all your code and trying to figure out what the problem is. If you still don't understand the error message, try to identify words that you do understand and the words that you don't understand. You can always Google search for the words you don't understand. Or you can just copy the whole error message and paste that into a Google search. The other technique is to use working code samples and compare it to what you have to try to figure out what went wrong. We've already given you some code to look at in the last few videos, and another good resource is the Common Android Views cheat sheet that we'll provide you. Here we see the names of different views, and we also have code snippets as well as a preview of what they would look like on the device. You can always compare your code to what we have here and see if there's any differences. The third technique is to use undo. If you're paying attention when you type, you should be able to see pretty quickly when you typed something wrong. Try undoing the last few keystrokes to see if any of those fix the error. As we showed you before, you can hit Command-Z to undo a change or Command-Shift-Z to redo a change. On Windows, it's Control-Z to undo and Control-Shift-Z to redo. Or in the XML visualizer, we have these nice handy buttons for undo and redo. If you really don't know what to do, you can always hit this Reset Code button, which brings you back to the original code that we gave you, which should work. The fourth technique is to just ask for help. You can reach out to other students on the peer chat in the lesson or on the forums. Oftentimes, just talking to another person will help you work out your errors. Don't be afraid to ask for help. There's a lot of really nice Android developers out in the community who are willing to help you. In fact, being able to ask for help is an important skill for developers. There are no bad questions. The more you practice, the better you'll be at knowing who to ask and what to ask them in order to help you get to your answer faster. You can also take a screenshot of the work that you're doing, whether it's on the phone or in the XML visualizer, and share that along with the code on the forums or in chat so that people know the context in which you're asking. Check out the instructor notes for more details. Okay, so here's a chance for you to practice some of those techniques. I have some code here that has errors. If you click on the link below, it'll bring you to the XML visualizer with this code already populated in there. There's a bunch of error messages, so I want you to try to read them and try to resolve the errors. Then come back and describe at least 2 problems that you saw. For extra credit, tell me if you discovered all 4 problems. Let's start by reading the first error. It says on line 1, the tag text is not a supported opening tag. So if we look at the line numbers, line 1 corresponds to this one. And indeed, we see that the view name should be TextView without a space there. And it should be camel case as well. So the capitalization is correct, but we need to get rid of the space. So now it recognizes that TextView is what we're talking about. That reduces 1 error. Cool, so now 3 more to go. The next error says that the tag TextView should be self-closing. This means it should end with a / and closing angle bracket. So if we check the code, it should be a self-closing TextView tag, but we only see the closing angle bracket. It's missing the, so we add that in. There you go, and now we're down to 2 errors. Cool, so the next one says the attribute Android layout height does not support the value 150, which is on line 4. So we go to line 4 and then we see that this code is incorrect. We may not know what's wrong with it though, so we can compare it to the layout width line above, since width and height are pretty similar. So here we set the width to be 150 dp. We remember dp from our earlier discussion of it, and indeed we're missing dp for the height, so let's add dp. Woohoo! And now we're down to 1 error. And the last error says the color at Android color darker gray is not supported. Did you type it incorrectly? Yeah, so in my mind darker gray is not a color, but darker gray is, so that is a typo, so I'm going to erase the O, type an A, and yay, our device now updates to show a preview of the text view. Oh, there's one more thing. This happy birthday text is actually spelled incorrectly, but there are no errors for that misspelling. That's because the text for a text view can be anything inside these 2 quotes. So you can misspell anything that you want, or you can spell it correctly. It really doesn't matter, and it will just show up like that. When you're creating your app, we're not checking for the rules of English, we're checking for the rules of XML syntax. Okay, so you've had your first attempts at writing code and fixing errors. This type of experimentation is a critical part of learning Android development. Let's talk about the size of views now. We know that the width and height are expressed in dp values, or density independent pixels. This makes it look good across a range of different devices. However, there's still room for improvement in this UI. If I change this text here to be something longer, for example, wait, today's your birthday? Notice that the text updates here, but that it wraps to 2 lines. Ideally, it would all be on 1 line because there's plenty of screen real estate on this side. The reason the box didn't change size is because we gave it a fixed width and height of 150 dp. When you set a very specific value for width and height like this is called hard-coding a value. It's generally considered not good practice because if the text ever changes like this, then it looks funny. We have to go and change the width to something like 200 so that it fits all on 1 line. But it would be such a hassle to keep updating the width and height based on what the text is. You might not know what the text is until later. For example, if you have an app that's showing news articles, the title of each story may change, and you don't want your UI to break if you have a really long title or a really short title. So in Android, we can solve this problem by setting the width to be a special value called wrap content. This adjusts the width of the text view so that it's precisely the width of the content inside of it. It's not too short and it's not too large, it's just right. Similarly, for height, instead of setting it to 150 dp, we can set it to the special value of wrap content. Then the text view will update so that the size of the text view is only as tall as the text inside of it. Now, setting wrap content for height or width is very powerful because you might have content beside it on the right here, which will now be shifted over because you don't have this excess space in the text view. And similarly, if you have other text views below this, now they can shift up to right below this first text view. Back to the news app example. If this was the story title, you wouldn't want the story description to be all the way down here, 150 dips away. Instead, you'd want the description to be right up under the story title. Zooming back out, let's try a shorter string. Okay, it's time for you to practice now. We want you to change a couple things with the code. Change the width and the height of the text view to be wrap content. Then change the text to be a really long sentence or paragraph so that it displays more than one line of text on the device preview. You can even type out the full birthday song if you wanted. That's pretty long. The code to get you started is linked below. So the quiz said to change the width and the height to be wrap content. Now these two values don't have to match every single time, so I can set one to be wrap content and the other to be a fixed value like 150 dips, and then you see it update here. And then we see that happily the text view size has now shrunk to fit the content inside of it, so it's only as wide and tall as the happy birthday text inside of it. Great, so now the second part of the quiz was to change the text so that it's a lot longer than just one line of text. We wanted to go to 2 lines of text on the device here. Let's change the text inside the quotation marks here. I'm going to pick the happy birthday song. So, happy birthday to you, happy birthday to you, happy birthday, dear Jenny, happy birthday to you. Jenny's our teammate who keeps us on track and makes sure that we're shipping this course to you on time. Okay, so now we see that the text view, which is marked by this gray background, has now expanded in height because now there's more text inside of the text view. That's pretty cool. It did that automatically without having to change the width manually. If you haven't already noticed, the text is kind of tiny on this device screen. I mean, my eyesight is terrible, so I really need it to be a lot bigger. Luckily for us, there is an attribute that we can declare to change the text size. Oh, but wait, there is an error down here. It says the computer wasn't able to understand my XML. Double checking the code, I see this new line that we added is actually appearing in black font, whereas everything above it has blue for the attribute name and red for the attribute value. So there's something wrong with this line. Oh wait, I see it now. / and the closing angle bracket are on this line up here. This is actually a common beginner mistake to add the attribute after the tag has been closed. Technically, this is like hanging out in XML limbo or something because it's not tied to an XML element. What we really want is to copy these symbols and move them down here. Ah, that's better. So there's no error, and this is valid XML, and then our font is bigger. Woohoo! It's much more readable now. Note how the text size is set to be 45 SP. SP stands for Scale Independent Pixels. It's a unit of measure similar to DP, which makes the app look consistent across different devices of different densities. Now, SP is only used for fonts because it adjusts based on the user's preferences and settings for text size. Let's look at that now. Let me show you where the setting is. Go to the Settings app, and then tap on Display, and then there's an option for font size. If you click on that, you can see the different font sizes. If I click on Huge, then it increases the font size of everything. So always use SP to declare your font sizes so it will scale up or down according to the user's preference. In a moment, you'll change the text size of the text view. However, I first wanted to show you one thing. This is the Material Design spec. Material Design is a new design language developed by Google to help people create consistent and beautiful apps across different devices and platforms, like web and mobile. The design specification, or design spec for short, highlights the best practices for designing your app. It provides guidance on the layout of your app, visual style, imagery, animations, and much more. There's also a section on typography, or fonts. it lists a whole bunch of information here that you can read later, but the most important thing is this guide here that talks about the recommended text sizes. If you're displaying a really big header, you can use some of these text size values. If you're trying to do a title or some body text or a caption, you can use some of these sizes. This will help guide you on what types of values you can pick depending on what your use case is. But be careful, because if you pick too many type sizes or styles in your app, it can be really overwhelming for the user. So just pick a couple of styles to display the information that you want. When you change the text size for the text view, try a couple of these values here. Go ahead and change the text view font size using the material design spec. And then if you're up for a challenge, you can try learning about the text appearance attribute from the Google+ Android Dev Pro tip that I've posted below. And then you can try this in the XML visualizer as well. The link to the XML visualizer with the code for you to get started is linked below. Okay, I'm going to choose a really big font, and then I'll try a really small font. So I picked Display 3 here, which is 56 SP. And remember to add the attribute before the tag is closed. So I'll hit enter here and then add text size attribute. Cool. And then the text is giant over here. Okay, now I can try a smaller size of maybe some body text, which would be 14 SP. So I'll erase this and then say 14. And then it's tiny again. Cool. Okay, so we finished the first task. The optional challenge was to try learning about the text appearance attribute on your own from the Google+ Pro tip that I included a link to. Let's open that up now. So this is an Android Dev Pro tip that was written by yours truly for the Android Developers Google+ page. If you haven't already, you can follow the Google+ page for Android developers to get the latest news on Android development. Or if you prefer Twitter, you can follow our account there. So basically, in this short pro tip, I talk about, again, how too many font sizes can be visually distracting for your user. So you can use the recommended font sizes in the material design spec, or you can also choose from a standard set of type sizes provided by Android, which is small, medium, and large. So instead of text size, you set the Android text appearance attribute to be Android text appearance large, or you can set small or medium. These text appearance values map to these SP font sizes. So if these ever change in Android, then your code will automatically get the new value. Using text appearance is great because you don't have to worry about specific SP values, and you can still be consistent with other apps on the device. For example, for a title, you can use large. For a list item, you can use medium, or for a caption, you can use small. So these are good buckets to work with. We can try them out in our code by just copying this line here. I'm going to use Command-C, or you can use Control-C if you're on a Windows machine. Go over to our code here. I'm going to delete this text size line because we're going to add text appearance. I hit Command-V or Control-V. So now Android text appearance is text appearance large, and you can see that the preview has updated to have the larger font size. That's pretty neat, right? And you can also change this to be medium or small. So in general, this is a really useful tip to know if you don't want to declare specific SP values. So if you have no idea which SP values you want to use, you can just pick from small, medium, and large. You're doing awesome. Let's look at one more thing you can change. Notice how this says Android color and it says dark or gray. I want to change it to something like black, or maybe something like white. And we see the device updates on the right here. How about if we change it to my favorite color, blue? So it doesn't exactly work because blue is not a supported color. There's a limited set of colors provided by Android, but you can still access a whole range of other colors by specifying the exact hex color code. You can find those again in the material design spec for color. So each of these colors is given a name from the material team, like 50, 100, 200. So let's choose this blue here. You can double click to copy it and then go over to the code, and then instead of blue, I'm going to replace this with hashtag and then the hex color code. Cool. So now the background of the text view is this blue color. It looks pretty nice. So now you might be wondering if you can also change the text color. And yes, you can. So I'll add it right here. Android text color equals, and I can specify in quotations the hex value. So go back to the color guidelines, and I'll just pick a random color. I like green, so this color will do. Copy that, and then paste that here in between the quotes. Hashtag, and the hex code. And cool, now the device shows the green text color on the blue background. Now it's your turn. Change the color of the background and the text of the text view to 2 different colors from the material design spec. This is linked below, as well as the XML visualizer that has your starter code. Have fun! Okay, so hopefully you picked some colors from the material design color palette. I like this purple 500 color, so I'm gonna go ahead and copy it. Then I'll go over to the code and then change the background color to be hashtag and then the hex code. Then the background of the text view updates to the purple color. Cool. Now to change the text color, I'm going to write Android text color with a capital C and then put double quotes. Okay, so then I'll go back to the color guidelines and pick something like, maybe this yellow looks good. Go over here and then paste it in between the quotes. Oops, I forgot the pound sign, and it says this color is not supported, so I need to put the hashtag symbol in first. Cool, and then we got yellow text on a purple background. It looks pretty awesome to me. We played around a little bit with TextView, and the other view we want to learn about now to make our birthday card is the ImageView. Now here's the XML for ImageView. Let's look at the lines one at a time. The XML element starts with an open angle bracket, ding, and then the name of the view, whoosh, and then the list of attributes, pew, 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 pew. Then it's followed by a / and then a closing angle bracket, boom. When we wrote the XML for TextView, it displayed text on the screen. So now when we write ImageView here, it displays an image on the screen. The first attribute is something we haven't seen before. It says Android source equals @drawable/cake. This is saying that the source for this image should be found in this file here. The file name is called cake. We use the @ symbol to say that we're referencing a resource in the Android app, and drawable is the resource type. A drawable is like a graphic that will be shown on screen in Android. And again, cake is the file image name. We don't include the file extension. Like, you don't need to say if it's a JPEG or a PNG image, just say the file name. If you're wondering where this image came from, well, we handled this a little bit differently in the XML visualizer compared to the app. But basically, we loaded in a bunch of images beforehand so that you can use them to practice in the XML visualizer. When you build your app in Android Studio, you're going to have to add images manually into your app, into the drawable folder. Now, if I try to reference an image that doesn't exist, for example, the toys image does not exist, then there will be an error because toys is not a valid image. So make sure that you only reference images that are available. So let's change it back by hitting undo. Now we have the width and height, which are set to be wrapped content, so that the image view is only as big as the cake image inside of it. Lastly, we have this attribute called Android scale type, and it's set to be center. Scale type tells the device how to scale up or scale down the image based on the bounds of the image view. Let's see what that looks like. Now you can see the cake image showing up on the device. The cake image is actually pretty large, and it's larger than the screen size. So when we say scale type, it doesn't change the size of the image, it just centers it. So we see that the cake image is actually really big, but this is the center of the cake image. We can set other values for scale type, such as center crop. This scales down the image to fit the height and width of the view. In this case, we're constrained by the size of the screen. We also maintain the aspect ratio of the original image so it doesn't get distorted. Once we scale it down, we also center the image and then crop it so that it fits this view size. When displaying photographs, I like to use center crop. This is because it's typically okay to crop off the edges of the photograph in order to achieve this edge-to-edge look. When images go edge-to-edge without any white border or anything, this is what we call a full bleed image. We use a lot of full bleed images in the material design guide. Here are some examples. You see how the images go edge to edge here, and it gives it a nice immersive feel. Okay, now it's time for you to try. Specifically, we would love for you to be able to change the height and width of the image view to be a fixed dp value. Try something like 100 dp. Then change the scale type between center and center crop. And you can also adjust the height and width of the image accordingly. For example, what happens if you change the height and width of the image view to be greater than the size of the device? Or what happens if you set the height and width to be something smaller than the size of the device? In those cases, you may see different behavior for center and center crop. Also try to change the image to something else by checking the available images link. We've included a small version of the cake image as well as a larger version so that you can try the different scale types. We also included an Android icon. Use the link below to get to the XML visualizer. If we try the smaller image, then we see that the image is actually smaller than the size of the screen. So it doesn't matter if we choose scale type to be center or center crop, the full image will be able to be shown in the view. And this is what it looks like with a photograph. Now let's try the icon. That was called Android. So the size of the icon is smaller than the size of the screen, so if we do wrap content for the width and height, then it should fit on the screen. It doesn't matter if we use center or center crop. Now what happens if we set the image view to be larger than the device size? Say we pick a really large number, like 900 dp in width and height. Then the image view will take up a size larger than the screen size, but the scale type is set to center, so the icon will be centered within that humongous image view. If we choose center crop though, the system tries to scale the image up to be a square of 900 dp by 900 dp, and then it centers and crops the image. Now that you've experimented with the ImageView XML, hopefully you have a better idea of how to display images in your app. The documentation for Android is on a site called developer.android.com. It contains a lot of helpful information such as code samples, tutorials, and articles. You can think of it as an instruction manual for how to build apps. I use this site daily, and oftentimes I get to it using a Google search. I'll show you what I mean. Let's look at the documentation for TextView. So I search for TextView Android. The top link that comes up is a developer.android.com site, so I click on that. This is what we call the reference documentation for TextView. I know there's a lot of information on this page and it can be overwhelming, but usually when you're looking at reference documentation, you're trying to solve a specific problem, so you can actually filter out all the unnecessary information that you don't need. When I come to this page, I check that it is indeed for TextView. I may read the class overview, and then I can scroll down. This is the interesting part. It lists out the XML attributes. These are all the possible XML attributes for TextView. It also includes a nice description on the right-hand side for what it does. Now you don't need to memorize all of these attributes. In fact, I haven't used some of them. I usually work with a small subset of them on a regular basis. But I know that if I ever need something special, I can always come to the TextView documentation to find that specific attribute. Oh, here's one that we recognize, Android text size. So click on it, and it links to the description of this attribute. It says that this controls the size of the text, and the recommended dimension type for text is SP, or scaled pixels. For example, 15 SP. Cool, so we learned this earlier, and if you ever forget, you can always come back to the TextView documentation and look up what the attribute is. Now say, for example, I don't know what the exact name is. In your web browser, you can use the Find feature to search the page. The other way to open up this Find window is to use Command F on Mac or Control F on Windows. Then I can type in what I'm looking for. Say, for example, I'm looking for a way to capitalize all the letters in a text view. This might be useful, for example, if I'm trying to show tabs like this, or if I'm creating a snack bar at the bottom of the screen, like this undo text here is in all caps. Buttons are also in all caps. Going back to the TextView documentation, I can search for caps. I can browse through all the search results, but these look pretty good. It says that there's an XML attribute called Android text all caps. And this description says to present the text in all caps. If I click on it and read the description, it sounds like what I'm looking for. And it says the possible values for this attribute are either true or false. So I can try this out in code now. So going back to the XML visualizer, say I have this text view on screen, and I want to change it to be all caps. According to the documentation, I can add an attribute here that says Android text all caps, and then I can set it to be true or false. If I set it to true, then look, it's all in caps. Cool. The nice thing about this attribute is that I don't have to go and change the text, like, oh, the possibilities, and capitalize everything. Instead, I can leave the text as is, and all I need to do is just toggle this attribute to change it from true to false. Now it's your turn to practice. Being able to look at documentation and then update your code accordingly to try it out is a really useful skill to have. That means you don't have to memorize everything you could possibly ever want to do in Android. It's only a Google search away, and you can find it when you need it. So first, I want you to Google search for TextView Android to find the reference documentation for TextView. Then I want you to use the Find feature in your web browser to search the page for the XML attribute that makes the TextView text bold or italic. We haven't covered this XML attribute before, so this is an opportunity for you to learn it on your own. Once you find something that might work, go ahead and try to use it. If that doesn't work, then no problem at all. Just keep going back to the documentation until you find the one that works. Okay, so I asked you to search for TextView Android. Usually when I do a search, I always add the word Android at the end of it so that it only shows me Android results. The first link is for TextView, and it's on the developer.android.com site, so I'm going to click on it. I can ignore most of the information on this page, except I do want to verify that this is indeed for TextView. I can read the class overview, but the most important thing is down here, the XML attributes. So I can manually scroll the list, but that will literally take forever, so I'm going to use the Find feature that I talked about earlier. The quiz question was about finding an attribute that would change the text to be bold or italic, so I'm going to search for the word bold. Cool, so let's look at this description. It says style, bold italic or bold italic for the text. That sounds pretty good, so I can click on this attribute. For Android text style, it seems that the different values are normal, bold, or italic. Let's try it out. The documentation says that if I add Android text style attribute, then I can set it to be bold, italic, or normal. So let's try bold. Nice, and it bolds the font. And let's be adventurous and try italic as well. Awesome, it italicizes the text. So this was an example of how you can look at documentation to find new attributes that you can set on your text view. In the future, when you're working on something and you get stuck or you don't know how to do it, remember that you can always use documentation as a resource.
My name is Kirill Grushnikov. I've been at Google for the last 5 years, and I do client work, UI work on the Play Store.
Okay, awesome. And what do you like about it?
Well, I always liked writing code and seeing pixels light up on the screen. So this is the Play app, Google Play app. Starting from top to bottom, we have the search box, and we have this what we call quick links to go to various subsections of the app and then of the store. And then we have different content here. So we have clusters of cards. We have this we call a banner that gets you into some other place in the app. You can go into the details page of a certain item, let's say Angry Birds Telepop, and this is what we're showing here, kind of the mix of information that developer has provided. We have the video of the app, then we have the short description of the app, screenshots, then we have the user provided content, reviews and ratings of that app, little bit more related content, and then here a couple of links, and you can go and also from the details page you can start the install process. This is the permissions, and then you go and accept them, and it starts, you can see over here it starts installing it.
So the students have been learning about text views, image views, buttons. Can you point out a couple of those in the app?
Yeah, so back to the cards, if we look at this Star Wars Rebels. So the card itself is an extension of a view group, but it can be as simple as an extension of a relative layout. And then we have this thumbnail is an image view. Then we have this Star Wars Rebel is a text view that goes to maximum of 2 lines. Rating bar is, well, rating bar. The free is text view, and the overflow dots is an image view with a source set to a certain PNG that looks like 3 dots. And then the same for the quick links. So it is a relative layout with the image view on the left, and then the text view in single line mode going to right of that image view and extending however much it needs. And it has its background set to a certain drawable that has a green background with rounded corners. So essentially, as you say, it boils down to taking these very basic building blocks, text views, image views, sometimes rating bar, progress bar, spinner, checkbox, radio button, and combining them based on what your design shows on a particular screen.
Yeah, that's so cool because these students are learning this in the very first lesson of Android, and you're using this every day in the Google Play app. You mentioned working with a designer, so can you describe what that process is like?
So it starts from the product people, and then it goes into discussions with design and engineering on what are the screens that we are talking about, and how hopefully already at that point on the design side we start thinking about how it adapts to smaller screens, to larger screens. After that, we do this kind of iterations on putting something on the screen and start validating the overall approach, because sometimes you have a static mock or maybe a motion mock from, like, After Effects or whatever tools the designers are using, and you see it on your desktop screen, and then you put it on the phone and it feels quite different because you have a smaller screen, or because it's a touch interaction, or maybe because you are depending on all these great big images, but the network is slow, and so you start with this screen that 5 seconds doesn't display anything. And so hopefully throughout this iterative process where we put something on the screen, not necessarily pixel perfect, then we can go back into the product level discussions and see, okay, what do we need to tweak?
So for developers who don't have a designer to work with, do you have suggestions on what they can do to make their app look better?
I would suggest going to the website for material design and get acquainted not necessarily with the finer parts of motion arcs or all those interpolators, but focus on the bigger picture. So to have consistent grid across the entire app, what we call key lines, or what the design calls key lines, vertical and horizontal, where elements align to certain visual rhythm and they don't feel just randomly thrown onto the screen. And so you have your toolbar, you have maybe your other parts of your Chrome, like the navigation elements in your screen, and then you have the content itself. So it's great when it all aligns to the same grid, and you have a little bit of margins on the sides, and things are not too close to each other. Then you have typography, which is a great way to visually convey the relative importance of different things. So if you talk about something like inbox or like Gmail or like an email app, so if everything has the same typographical language, if everything is the same color, the same size, and the same style, then it's not really easy to scan it. So maybe you would want there to make the sender a little bit bigger, like the sender name, or maybe the title, or like the first few words of the subject to be bold. And that would allow the user to more quickly scan. Depends once again on your content. But I wouldn't recommend necessarily going with too many styles or too many sizes. 3, 4 styles used consistently across multiple screens allow the user to kind of get, even on a subconscious level, to get kind of a picture of how to get things done in your app and not necessarily fight to understand where the information is that he or she is looking for. And the last thing, colors. Use a little bit of, especially with material, it kind of leans toward using big splashes of saturated colors, which looks great, especially if it goes into the status bar on Lollipop devices. Identify maybe, like, you know, what we call them, accent colors and primary colors. Identify a couple colors and use them to kind of, like, you know, to style the Chrome of your app. So like status bar, action bar, maybe a little bit in the drawer, in the navigation drawer. And use highlights or accents for the floating action button, or maybe for, like, you know, to draw attention to a certain, like, very important element, what you consider an important element. And I think these three go a long way towards, like, you know, emphasizing a little bit more, like, you know, the visual style of the app. And of course, if you have an opportunity to team up with the designer, that's always great.